Good morning. Okay, so what we're going to do today is we're going to move on to a new theme, okay? Now, I say it's a new theme. In reality, it carries on from what we were doing in theme 2. Okay, it carries on from what we were doing in theme 2. So you remember, in the last theme, we started off with kind of ordering and counting objects, literally working out the number of ways that things can happen, and then we moved on to what we just looked at, which is conditional probability. Now, today what I'm going to do is try and link together this idea of probability, okay, but look at it in a more kind of concrete way, okay? And I want to look at it from the perspective of a function. Now, has anybody met functions before? So what do I mean by a function? Does anybody know? So I could, for example, mean something like this. F of x equals x squared. What does that mean? It literally says, okay, it literally says you give me a value, which I'm just calling x in this case. It literally says you give me a value, I then do something to this value, okay, and then I get another value out the other end, okay? Now in this case, what am I doing to that value? I'm squaring it, yeah, I'm squaring it. So for example, if I give you 3, what would come out the other side? 9. If I gave you 6, what would come out the other side? If I gave you negative 10, what would come out the other side? 10. Be careful. 100, right? 100, good. So literally, a function is you give me a value here, I do something to that value, and I get out the other side. So it's literally just following some rule. Now, what the idea of a probability distribution is instead of you giving me a value, you give me an outcome. Okay, so you give me an outcome on this side, and I will find the probability of that outcome on the other side. Okay, so rather than just working out probabilities like this, so just remind me, if I want to work out the probability of an event, if I want to work out the probability of something happening, how do I do that? How do I do that? Remember, it's just a ratio of two things. So for example, if I want to work out the probability of getting a heads on a fair coin, how would I go about doing that? Boys, what do you reckon? Boys, what do you reckon? How do I work out the probability of something happening?
Outcome of the interest over the total of outcomes.
Good. Well done. So it's the favourable outcomes divided by the total number of outcomes. Does that make sense? Yeah? Now that's at the moment how we work out probability of an event, but what I want to do is try and link together all of those probabilities in some nice, neat way. Okay? So today we're going to look hopefully a little bit at random variables, a little probability distribution. If we have time, we're then going to move on to a bit of expectation algebra. Okay? Now at the moment I don't expect you to understand what expectation is, but hopefully by the end of the day you should do. And then if we have time, we'll have a look at some uniform distributions. Okay? And then we'll move on to the rest in the next lesson. Okay? So for the moment, can I give you 5 minutes to have a look at these words? I put 4 words on the screen. I want you to discuss in your groups what you understand by those words, okay? So we've got variable, random variable, discrete variable, and continuous variable. Some of these we've met before, so just see what you think. Okay, so what do we reckon? What do we reckon? So first of all, has anybody got any ideas? What is a variable? It's something which can change, yeah? It literally sounds like varies, yeah? So it's something which can change, yeah? Can anybody give me an example of a variable? Height. Any other examples? Age. Any other examples? Hair length. Perfect. So these are all examples of variable. Now the definition which I've got is it's literally a characteristic which you're interested in measuring. So if you set up an experiment and you go out and you collect data, your variable is the thing which you are interested in measuring. Does that make sense? Yeah, does that make sense? Good, fantastic. So what about a random variable then? What about a random variable? So what's the difference between a variable and a random variable? Okay, so it's unpredictable, yeah? So you're literally playing on this idea of randomness, okay? Here's the definition which I've got for random variable, okay? So it's a variable that is the result of a random observation or experiment, okay? So as an example, you may want to go into the college and you may want to find the distribution of ages in the college, okay? Now, fairly obviously, it depends on who you ask. So if you're picking somebody at random, okay, then the observation which you get should be a random variable because it's the result of probability. Is that clear? Yeah? Yes? So the example which I gave was if you go into the college, okay, and you just pick somebody at random and you want to look at their age, okay, that would be an example of a random variable because it depends on who you pick, yeah? If you're picking somebody truly at random, okay, it depends on who you pick. They could be 18, they could be 19, they could be 20, but it's the result of probability. Does that make sense to everyone? Good, fantastic. Yes?
But if it was students only, like
Yes, exactly.
not any staff or like any person.
So that's one of the conditions which you have to define when you do your experiment, okay? Are we just going to look at students? Are we going to look at everybody in the college? Because you're absolutely right. If we started looking at everybody in the college, for example, including staff as well, then suddenly the outcomes which you could get would be much older. Make sense? Yeah? Good, fantastic. Now, I think the next two go together. So a discrete variable and a continuous variable. Can anybody tell me what the difference is? What's the difference between a discrete variable and a continuous variable? Good, so discrete is only whole numbers, okay? So discrete is only whole numbers, whereas a continuous variable is what? It can be any value, right? We've met this definition before. So literally the way to think about a discrete variable is it's a value that can only occur in set intervals. So can anybody give me an example of a discrete variable? Age, perfect example. Yeah, you can only be like 1, 2, 3, 4, or 5, yeah? You can't generally be 1.76 recurring years old, yeah? We usually say you're 1 year old or you're 2 years old. That make sense? Yeah? Whereas continuous variable, what's that? Good. Time would be perfect. Yeah? Distance, yeah, perfect. Heights, weights, things like this. These are just basically things that can occur at any point along a number line. Yeah? So I've got an example there. So a discrete variable is a value that can only result in usually integer values. What does integer mean? Just remind me. So an integer is usually a whole number, Now, in actual fact, it might be that it's like every 0.5, but generally a discrete variable can only occur in integer values. Good. And I put an example there, number of people. And if you have a look, continuous variable is a value that can result in any value you like. Okay, so 0.7 recurring is absolutely fine. That make sense? So an example there is height. Another example will be weight. Another example will be time. All good? Fantastic. Okay.